Hi, good morning, everyone. Today we are going to discuss some basics of polynomial functions, domain, codomain, and range. And we are going to see some basic sketches of certain polynomial function and how to find the domain and range for most of them. Okay, so let's start. So what is a function? A function, as we know, mathematical relationship between independent variable x or the argument of the function, and this relationship would map x into y, which is the output of the function or the dependent variable or the image. Okay, so the domain is the set of all possible values of the argument or x or the independent variable. And sometimes, we see this notation of the functions. We say f double dot and then d, let's say set, right? And then a small arrow, like an arrow, and then into e, another big set. So this set here is called the domain, and that set here e is actually called the codomain. The codomain. By definition, a codomain is, it refers to all the possible. Now I have here like a comparison because maybe you never heard of codomain before, but I mean it's good to know like a kind of definitions or basic definitions. But then in the rest of the program, we are going actually to deal with the range. So I just want to, for the sake of completeness, let's at least know what is the difference between codomain and difference between the codomain and range. So the codomain refers to the possible set values that might come out of a function. Okay, in all the work that we are going to do in IB, MAA, high level, even first year of university, right? This codomain is basically the set of real numbers. So basically we are dealing with real numbers. Okay, so the set of real numbers, okay, no complex, no imaginary numbers. So the codomain is basically R. But does it mean that the actual image will also be the real number? Not necessarily. It depends on the actual image after you plug in the possible x values in the function and see what is now the actual image, the actual set or definitive set here of values that may come out of a function, and this is called the range. Okay, so the range here, it is basically a part of the codomain. Okay, is a subset of the codomain. And at the same time, this domain, again, this domain is the set of real numbers. So we started with input variables, right? Input values belongs to the set of real numbers. But does it mean that the domain of every single function is going to be the set of real numbers? Of course not. Why? Because we may have some restrictions. It depends on the function itself, right? So when you see this, I just want to mention, because this definition here is in the textbook, but it was not really explained clearly. And I see this arrow here, it means it gives me the domain and the codomain. Okay. Now let's have some examples, and let's talk more specific today about the polynomial functions. You see? Now see that this is actually extracted from Oxford textbook, one of the textbooks used in IB program. So see f double dot r arrow r. What does it mean? It's definition. Just r here is the domain, possible values, sure. So we deal with real numbers. Now here the second r, the second real numbers is codomain. Which means what? Which means also we deal with real number. That's it. So this is domain, this is codomain. But the actual domain and actual range, it depends on the function itself. Okay. Now let me first give some insights on the conditions for a function to be called a polynomial monomial. I'm going to step back first with monomial. So when you hear the word mono, what do you think of? Okay, mono. Say monomial. It means one, right? So monomial, okay, is a function consists of one term, of one algebraic term. Now, when you say, for example, okay, x, I'm going to make it easy to like keep it simple now. So x is a variable. Now this term here consists of a variable. If I, let's say 3x, if I add a coefficient to x, so this is a number, but still one term because they are multiplied, right? So 3x here is one term. So this is one term. It's called algebraic term, right? So if f of x as a function is going to be 3x, this is called a monomial because it is only one term. Okay. Now, next, pi. So when you hear the word binomial, what does it mean? It means bi means two, right? So you see two terms. Let's say, I don't know, x squared, right, plus 2x. So I have now, if I see algebraic expression. So let me now very, this is basics of algebra. So you see x squared this is called a term, right? And now another term is called 2x. This is another term. But then if I see plus or minus between two terms, so then I have what? I have algebraic expression. Okay? So algebraic expression formed of two terms is called binomial, right? And this could be another function. Let's say, okay, not f, let me call it g. That's fine. Whatever. G of x is equal to x squared plus 2x. Okay. Now you may guess the next one. Try. So try means what? Means three terms. So trinomial, right? So let's say x squared plus, I don't know, 2x minus 1. I added one another term, absolute value, right? And let's call it h of x. So now h of x is going to be x squared plus 2x minus 1. Now this is a trinomial. It means what? It means it is a polynomial, but formed of three terms. So all of these are examples of polynomial functions, right? Now, if more than that, you may just call it polynomial, right? I mean, of course, I mean, okay, so okay, so if it's more than three terms, so we can call it poly. So poly means what? Poly means many, right? So polynomial is just basically, and any one of those actually are polynomial, but just, you know, different terminology. Okay, so that is the first insight I would like to share about polynomial functions. Now, the second condition of polynomial function here, I talk about only one variable, which is x, okay, which is what we are going to deal with, okay, all the program until high level, no problem. It's only single variable. Now, the second condition for a function to be a polynomial, or for an expression to be a polynomial, that the exponents or the powers of x has to be non-negative integers. Have to be non-negative integers. You see here the form, you know, this is the form, all right? So an, which is the coefficient, right? X to the power of n plus another coefficient, x to the power of n minus 1 plus a1x plus a naught, which is the absolute value. Now, these are the powers, n minus 1, 1. So the powers here have to be non-negative integers. Now let me review some basics about what do I mean by non-negative integers. So when you look at the set of integers, z, basically we call it z, right? So the set of integers, you know, it has 0 in the middle, and then 1, 2, 3, point, positive infinity. On the other side, you have -1, -2, -3, point, negative infinity. Okay. Now these are integers. What does it mean? It means there is nothing between 1 and 2. There is nothing between 1 and 2. So 1 is an integer. The next integer is 2. The next integer is 3, right? So then we call, now we took 1, 2, 3, point plus infinity. We call it z positive, which is the positive integer. So the set of positive integers, these are 1, 2, 3 until positive infinity. And we called -1, -2, -3, point, negative infinity z minus, which is our negative integers. So now why didn't what is, how about 0? Why it is left in the middle? Because 0 is neither positive nor negative. That's why I could not take it to like with the z positive or the z minus. 0 is not negative, 0 is not positive. And that's why when I say the powers of the exponent or the exponents of the polynomial function non-negative integers, I did not say positive, I said non-negative. What does it mean? Non-negative means non-negative integers. Non-negative integers is going to be z positive union the value of 0, right? Because 0 is not positive again, right? You understand? So 0 is neither positive nor negative. So that's why non-negative means the positive and 0. Okay. Let me give you more examples. Now let me give you some examples. So a polynomial function. So I say f of x is going to equal, let's say 5, right? Now 5 here doesn't have any x. Like when you look at this expression here, I don't see x. Well, that doesn't mean, it means here x was there, but to the power of 0. And we know anything to the power of 0 is equal to 1. So anything to the power of 0 equal to 1. That's why 5 times x to the power of 0 equal to 1, which means 5. Now, here, I need to introduce one more definition, the degree of the function. So now the degree of the function is the highest power of x in the function. I mean, given it is one single variable. Okay? So degree of the function is the highest power of x. So now what does it mean here? It means this function here is 0 degree. Right? Because the power of x here is 0. Now 0 degree, we give it a name, constant function. So this is called the constant function. It is polynomial? Yes, it is polynomial. Why? Because the power belongs to 0 and z positive. The power is non-negative. That's it. Integer, non-negative integers. Right? Now, if you'd like to like sketch this constant function, what you expect, right? So this is the x axis, right? And this is the whole vertical axis, the y image, right? So if you plug in x at any variable, any value, you always get 5. You always get 5. So that's why the sketch of this function is very simple. It's just a horizontal line parallel to the x axis at y equal 5, right? Because you know at any value y equal 5, you put x equal 1, you hit y 5, x equal 10, y equal 5, x equal -3, y equal 5. Constant function, 0 degree polynomial. Okay. Now let me give you one example just to confirm the understanding. Let's say g of x is, let's say 1 over x. Now the question here, is it polynomial? Let's see. So 1 over x, we can express this as x to the power of -1. You can bring it up and change the sign of the power, right? So now you ask yourself, okay, the condition, the power has to be non-negative integers. Non-negative. I mean, x to the power of -1. What does it mean? It means this is not polynomial function. So this is not polynomial function. Why? Because the power is negative. Okay, one more example. Let's say h of x is going to be root x. Let's say root x. Now root x, square root of x, we can express it as x to the power of 1/2. Is it polynomial? Of course not. Why? Because the power is not integer. You see what I mean? So here, this is not polynomial because the power is not integer. So as a conclusion, the power have to be non-negative integers for polynomial functions. Okay. Now let's quickly have a look at certain graphs of polynomial functions of different degree. So the first one here, y equal x, x to the power of 1. So we call this first degree. First degree, another name of the function is linear function, and that's why it is represented by a straight line. Now, in terms of domain, let me just change the color here. So in terms of domain, okay, you look at the sketch, right? We can put x any value. You don't see any restrictions on the x values, right? So I can say here, okay, so the domain here is going to be the set of real numbers, because like there is no restriction, there are no restrictions on x. I can put x anything. You can look at the x-axis. And look at the range of a straight line. I mean, the straight line technically has no end and has no beginning, right? So the y values vertically, right? The y values can go up and down from negative infinity to positive infinity, which means the range now see, now I'm going to speak range now, not codomain. Just in the beginning, I had to for the definition. So the range here also is going to be the set of real numbers. So by coincidence, right, the range here is basically the codomain, no problem. Okay. Now let's have a look at part B. Part B, y equal x squared, the parent function of second degree y, because the highest power of x is 2. And we call this quadratic function. And it is represented by a parabola. Now, a parabola, when you look at x values to find the domain, again, I don't see any restrictions on x. I can put x any value, so the domain is basically a set of real numbers. But now, the range, I don't see any I don't see any images, right, below the x-axis, right? Why? Because actually x squared, it always refers to a positive. If you put x as negative, for example, negative 2, then negative 2 to the power of 2 is going to be 4 anyway, right? So whatever x is input here, whatever input, you always get positive number because it is square, right? So we can say here, okay, now in parabola, you always look at whether the minimum point or the maximum point. We can look, I can talk more details about parabola in later videos, but today I just want to give a flavor of the different polynomial functions. Okay, but yeah, but this is technically what you do. So see the range here of this parabola, you know, start from the minimum point is 0, right? So say, okay, it is from 0, closed interval, okay, up to positive infinity, open. So this is the range of this parabola here, okay? Sometimes you may express it as y is bigger than or equal to 0. It's fine. Okay, now look at this next one. Y equal x cubed. What's the degree of the function? Third degree. Why? Because highest power of x is 3. And you need also, as IB, MAA, SL, standard level, you need to be comfortable to sketch the parent function, at least of the first row by yourself. You need to be able to sketch a straight line, parabola, and y equal x cubed. The parent, at least the parent function. Okay. So domain is set of real numbers, obviously, right? Now the range of this function here, you know, like this function here is going to negative infinity and positive infinity. So the range here is obviously the set of real numbers. Okay. In the same time, x to the power of 4. In the same way, x to the power of 4, we call it quartic function. Quartic, what does it mean, quartic? Quartic means, and also this is called cubic function. So power 3, cubic function. Power 2, quadratic. Power 4, quartic. Power 5, quintic. Power 6, I don't know. Let's call it 6th degree. So I can call it 6th degree function. Okay. So the degree of the function, again, is the highest power of x And it is actually the first question I ask myself when I'm looking at a question regarding function. I ask myself, what is the type of this function? Is it linear? Is it parabola? Is it cubic? And so on. Okay. So quartic function, x to the power of 4. Again, if you put x negative number, right, you always get a positive because the power is even. Like negative 1 to the power of 4 is 1, right? So, but the domain is still the set of real numbers, right? So the domain here is the set of real numbers, but the range is going to be similar to, or basically the same as x squared, right? The minimum is 0. If you put x equals 0, you get y equals 0. 0 to the power of 4 is 0. But then that's it. I mean, this is the minimum, right? So we can say, okay, it is from 0, closed interval, right, all the way up to positive infinity, open interval. Okay. And the same way here, x to the power of 6, and the same x to the power of 5. So as a conclusion, the domain of any polynomial function is the set of real numbers. You can take it as a conclusion today. Okay. But the range, no, it depends. The range, it doesn't have to be a set of real numbers. Okay, so I hope it was helpful today. Now, thanks for watching again. And if you have any comments, questions, happy to receive your feedback. Okay, thank you so much, and see you in further videos. Have a wonderful day.